Yes, do you have any doubt? Am I not audible clearly? I am not audible. Am I audible? Samia, am I audible now?
Yes, sir.
Okay. So do you have any doubt from the previous class?
No, sir.
Very good. Okay, let's start from here. A new topic, that is variation of, write a topic, that is variation of molar conductivity and equivalent conductivity. Molar conductivity and equivalent conductivity with concentration or dilution. Basically, we need to see the variation of molar conductivity or equivalent conductivity for weak and a strong electrolyte on dilution. On dilution. Write it, dilution. Do you know what is dilution? That means you are going to add solvent. Yes or no, Samia?
Yes, sir.
So first of all, I'm going to introduce conductance for weak and a strong electrolyte. We are going to see for weak as well as strong electrolyte, because there will be different changes or different variation for weak and a strong electrolyte. So if we are going for weak electrolyte, do you know what is weak electrolyte? As I already told you what is weak electrolyte in the previous class. That means a electrolyte which is partially dissociated. That electrolyte is called weak electrolyte. Okay. Is that clear, Samia?
Yes, sir.
Now see, if you are going to dilute a weak electrolyte, that means dilution take place. If you are going to dilute a weak electrolyte, that means volume of solution will increase or decrease. Volume of solution will increase.
Yes, increase.
Just answer me whatever I am asking. Okay. If volume of solution will increase, that means we can say concentration of solution will decrease. If it is concentrated, it will be diluted. Yes or no?
Yes.
And if there is more volume, that means force of attraction force of attraction between particles decreases. Just listen to me carefully. If the volume of solution will increase, the distance between particles will increase. That means force of attraction will decrease. So conductance will increase. Again, I am going to tell you what we are studying is basically variation of molar conductivity and equivalent conductivity with concentration or with dilution. With dilution. Okay. So we are here. We are going to study separate for weak electrolyte if we are going to dilute it, and also for a strong electrolyte if you are going to dilute it, because there will be different variation of molar conductivity as well as equivalent conductivity when we dilute or concentrate it. So again, if there is a weak electrolyte and if you are going to dilute it, dilution increases, that means volume increases, or dilution increases, that means concentration decreases, that also means concentration decreases. Now you can see, if dilution increases, that means volume increases, that means particles are away from each other, that means force of attraction decreases. If force of attraction decreases, particles can easily move, that means conductance increases or not. Yes or
Yes.
no? See, what happens here is, in weak electrolyte, if you are going to dilute it for a long time, that means if you are going to add more and more solvent, what happens there is, there will be new ions will be introduced. New ions will be introduced because basically it will be dissociated, because the force of attraction is so low that it will be dissociated. So I am going to write here, new ions will be generated, will be generated. And if new ions will be generated, that means conductance is very high. Now what I want to say is that in weak electrolyte, generally 5% ions dissociated. But if you are going to dilute it for a longer time, that means volume increases, that means particles are very far away from each other, that means force of attraction very low, and that's why force of attraction between particles are very low. So new ions will be generated, that means it will be dissociated. If initially it is dissociated 5%, then finally if you are going to dilute it, it will be dissociated 10%. So 5% more ions will be introduced, and because of that new ions, here conductance will be very high. That means variation will be very high. Initially, if the conductance is low, then after dilution, the conductance will be very high. The variation will be very high. Is that clear, both of you?
Yes.
Now see, for a strong electrolyte, Madiha, is there any doubt?
No,
We
sir.
just started. Okay. Now see, for a strong electrolyte, again, same. If you are going to increase dilution, that means volume increases. Volume increases, that means force of attraction decreases, that means conductance increases, that means conductance increases. Abhi, hello, am I audible now?
Yes, sir.
Now see, For a strong electrolyte, if you are going to dilute it, that means volume increases. So particles are far away from each other. That means force of attraction between particles decreases. So they can easily move. So conductance increases. Now see, the variation in a strong electrolyte will not that much as compared to variation in weak electrolytes, because a strong electrolyte, that means alpha is equal to 1 or alpha is equal to 100%. So what happens here is basically all the ions is already dissociated. 100% ions are there, but due to the dilution, the force of attraction is very low, so they can easily move faster than the earlier. But the variation in weak electrolyte is very high because there are new ions introduced due to the dilution. Is that clear?
Sir, can you repeat?
Please write it, then I will explain it again. Okay.
Okay, sir.
Let me know when you are done with this.
Done, sir.
Are you done with this? Samia, Madhya?
Yes.
Now see,
Yes, sir.
in a strong electrolyte means the ions will be dissociated 100%. That means all the ions are already converted into basically electrolyte. All the electrolytes are already converted into ions 100%. So if the dilution increases, volume increases. Okay, and the distance between particles are very high, so the force of attraction decreases and conductance increases. Am I audible now?
Yes, sir.
Yes, sir.
Okay, okay. So see, what I want to say is that a strong electrolyte, that means electrolyte is already dissociated into ions, 100%. And what happens here is, if you are going to dilute it, volume increases and the distance between particles increases. That's why force of attraction decreases and conductance increases. But in case of weak electrolyte, what happens? Due to dilution, new ions will be introduced, and this due to this new ions, conductance will increase more than the strong electrolyte. So the variation in weak electrolyte will be more than a strong electrolyte. Is that clear?
Yes, sir.
Yes, sir.
Oh, are both of you done with this?
Yes, sir.
Sir, in this, the only difference is the variance of conductance.
In this, only difference is
The variance in conductance.
yes, yes.
Okay.
Now see, I'm going to write the point. Write a note, that is effect on dilution in weak electrolyte effect in dilution in weak electrolyte is more than that of a strong electrolyte, is more than that of a strong electrolyte. Please remember this. You know that. Are you done with this?
Yes, sir.
Now see, molar conductivity, that means lambda m, and here it is equivalent conductivity, that means lambda e. We have a formula, lambda m is equal to kappa into 1000 upon m, and lambda eq is equal to kappa into 1000 upon m. So always remember that due to dilution, wait a minute. When we talk about conductivity, that means kappa is defined as, I already defined it in the previous lecture. So what does this conductivity means? Conductance due to all the ions, conductance due to all the ions present in 1 ml electrolyte, So basically, the conductance due to ions present in 1 ml electrolyte, this is the volume. So due to dilution, you know that density is equal to mass upon volume. And if you are going to increase this, density decreases. And you know that due to dilution, volume increases. And when volume increases, conductivity decreases. Conductivity decreases. Is that clear? This point clear? Samia and Madiha?
Sir,
Now
can
see,
you explain it once again?
what I want to say is that conductivity is conductance due to all the ions present in 1 ml electrolyte. But now here we are doing dilution, that means adding of solvent, that means volume increases, and if volume increases, conductivity decreases. Conductivity decreases. Is that clear? Because density decreases, that's why conductivity is also decreasing. Okay, Madiha and Samia?
Yes, sir.
Okay, sir.
Now apply this formula here. If you are going to do dilution, that means volume increases. If volume is increasing, that means conductivity is decreasing. Yes or no?
Yes.
If volume is increasing due to the dilution, conductivity decreasing, and if conductivity is decreasing, molar conductivity is also decreasing, will also decrease. Yes or no? Because they are directly proportional. Madiha.
Yes, sir.
But now you also know that if volume increases, you know the formula, molarity is equal to number of moles of solute upon volume. So if volume increases, molarity decreases. So volume increasing, that means molarity decreases. And if molarity decreases, molar conductivity should increase, because molar conductivity, relation between molar conductivity and molarity is inversely proportional. Yes or no? Madiha, Samia.
Yes, sir.
So how we are going to see whether molar conductivity will increase due to the decrement of molarity, or whether molar conductivity will decrease due to the decrement of conductivity. In the same way, we can think of dilution increases, that means this will decrease, this will also decrease. And if you go for normality has also formula, number of gram equivalent upon volume of solution in liter. So volume increases, that means normality decreases, and if normality decreases, that means this will increase. So basically always remember that molar conductivity and molar equivalent conductivity depends more on molarity and normality. Experimentally we found that molar conductivity and equivalent conductivity depends more on molarity and normality. That's why on dilution, molar conductivity will also increase and equivalent conductivity will also increase. Is this clear to both of you?
Yes, sir.
So I am just write it, sliding it up. Please write. Wait a minute. Let me know when both of you are done with this.
Done, sir.
Very good. Now see the graph I am plotting. You will see the variation for weak as well as a strong electrolyte. This is lambda m molar conductivity, Siemens centimeter square per mole, and this is concentration raised to the power half. That means also written as under root C. C is for concentration molarity, and its unit will be mole per liter raised to the power half. The graph we experimentally plot it is like this. This is the variation for CH3COOH, a weak electrolyte. Weak electrolyte. And you have to study this graph from right to left, because if you are going from 0.4, just suppose this is 0.4 and 0.2. If I'm telling you that dilution increases, that means concentration decreases, yes or no?
Yes.
So this is the graph for on x-axis, it is concentration. So when you are going from right to left, you can see molar conductivity increases. This is graph for weak electrolyte. In the same way, if you are going to plot, this is 200 and this is 400. If you are going to plot the graph for a strong electrolyte, it will be a straight line. The variation in a strong electrolyte is very less than variation in weak electrolyte, because in weak electrolyte there will be there are introduction, or you can see production of new electrolyte, new ions. In weak electrolyte there will be production of new ions, whereas a strong electrolyte has already dissociated into 100% ions, but there will be only the distance between particles will increase, so that they will they will move faster. But in case of weak electrolyte, there will be production of new ions due to the dilution, infinite dilution. That's why the variation in weak electrolyte is very much as compared to variation of a strong electrolyte, variation of molar conductivity in a strong electrolyte. Is that clear?
Yes, sir.
Please write it.
Done, sir.
Done, everyone? Samia?
Yes, sir.
Okay. Now see, from this graph, we are going to have an equation, Debye-Huckel-Onsager equation. Debye-Huckel-Onsager equation. The graph, the equation is like, since it was a straight line, and this equation is only for a strong electrolyte, only for a strong electrolyte. As you know that a straight line has a equation y is equal to mx plus c for a straight line up. So on this base, we are going to have an equation lambda m infinity minus b under root c, only for a strong electrolyte. Only for a strong electrolyte. Now where lambda m equals to molar conductance at concentration C lambda infinity m is equal to molar conductance at infinite dilution, and B is basically constant. B is constant. Please write. Are you done with this?
No, sir.
Okay, let me know when you are done with this.
Done, sir.
Done, sir.
Very good. Now we are going to start a new topic for Lorentz law. So first of all, I am going to define it. Write with me. Lorentz law of independent migration of ions. Migration of ions. And you should know the Debye-Huckel equation is only for a strong electrolyte, and this Lorentz law is for weak as well as strong as well as weak electrolyte. For strong as well as weak electrolyte. So what does this law says? I'm going to write it. Write with me. This law states that the equivalent conductivity of any electrolyte, the equivalent conductivity of any electrolyte at infinite dilution, lambda eq infinity is the sum of equivalent ionic conductivities of the cation and anion given by the electrolytes at infinite dilution, So please write it, and then I am going to explain what it is. Have you heard of in class 11th? You have heard of equivalent concept? Yes or no? Equivalent concept or mole concept?
Yes.
So
Yes,
in
sir.
equivalent concept, we don't need to balance, but in mole concept, we need to balance, right? Yes or no? In mole concept, we need to balance, but in equivalent concept, we don't need to balance. Please write it and let me know if you're done with this.
Done, sir.
Sami, are you done with this?
Sir, 1 minute.
Okay.
Done, sir.
So what does it say? Law states that equivalent conductivity at infinite dilution, equivalent conductivity at infinite dilution will be equal to the is the sum of equivalent conductivities of the cation and anion. That means cation infinity plus C for cation and A for anion. We can take another example. C lambda C infinity, that means equivalent conductance at sorry, C for of cation at infinite dilution lambda infinity A, that means equivalent conductance of anion at infinite dilution. So basically you will get to know that this will be an electrolyte, whether it will be a strong or weak electrolyte. It will be dissociated into ions, and that ions will have some equivalent conductance or molar conductance, and that depends upon cation or anion. I will explain it again. Please write it and then let me know. Madhya, let me know if you are done with this.
Done, sir.
Now see, I'm going to take a general example of weak an electrolyte. There is AXBY. If you are going to dissociate, it will be XA plus Y plus YB X minus. Yes or no? This will be dissociated like this. Now, if you are going to write equivalent concept of this, it will be equal to whatever is the charge 1 by y lambda, wait a minute, lambda eq of a plus y plus lambda eq of b x minus. This will be the equivalent conductivity. But if you are going to write lambda naught infinity, it will be equal to, since I told you that we don't need to balance in equivalent concept, but we need to balance in mole concept. M for molarity, EQ for equivalent concept. So we are going to balance it since X mole. So X into lambda M of A plus Y, that means cation, and Y mole of B, that means Y lambda M of anion. This will be the formula. So please write it. X and Y is what? X is stoichiometric coefficient of cation, and Y is stoichiometric coefficient of anion. Let me know when you are done with this. Are you done with this? Madhya?
Done, sir.
Now see, I'm going to give you a question. Just try it. Calculate lambda naught infinity of oxalic acid. Do you know the formula of oxalic acid? It will be H2C2O4. Okay, we need to calculate lambda naught M for oxalic acid, and it is given that lambda EQ, this will be equal to Na2C2O4 400 per ohm centimeter square per equivalent. Also, it is given that lambda naught M H2SO4 will be equal to 700 per ohm centimeter square per mole. Also, it is given that lambda EQ for Na2SO4 will be equal to 450 per ohm centimeter square per equivalent. So we need to calculate lambda M infinity for H2C2O4. So please do it. Can you do this, or I should explain it?
Sir, can you explain it?
See, first of all, see what we need to calculate is molar conductivity of H2C2O4 at infinite dilution, and what it is given is equivalent conductivity, molar conductivity, equivalent conductivity. So first of all, we need to change this equivalent conductivity into molar conductivity. Are you getting my point? Lambda m, so that we can easily do this. Okay, is that clear?
Yes, sir.
Now see, I have given you a relation between lambda eq will be equal to lambda m upon n factor. N factor is basically charge. So we can easily calculate lambda m will be equal to n factor into lambda eq for this as well as for this. Now see, what will be the m factor? N factor. Total charge on the negative will be -2, yes or no? Here it will be +2. So the n factor is 2. So lambda m for this, lambda m infinity for Na2C2O4, Na2C2O4 will be equal to 400 into the charge it. So it will be 800 Siemens centimeter square per mole. Are you getting my point?
Yes, sir.
In the same way, we are going to calculate lambda naught m for Na2SO4. What will be the n factor of Na2SO4? Can you tell me?
2.
2. So 2 into 450, it will be equal to 900 Siemens centimeter square per mole. Is this clear?
Yes.
Now, tell me the value. Lambda, wait a minute. Now tell me the value. Lambda m infinity for Na2SO4. What it was? 900
800.
Siemens centimeter square per mole, right? 900
Yes, sir.
Siemens centimeter square per mole. Now tell me lambda m infinity for Na2C2O4 will be equal to 800 Siemens centimeter square per mole. Again, lambda infinity m for H2SO4 is given as 700 Siemens centimeter square per mole. Yes or no?
Yes, sir.
Now, if you are going to dissociate it, it will be 2 into lambda m Na plus. Yes or no?
Yes.
Na2, if you are going to dissociate it, it will be 2Na plus plus SO4 minus 2, and we need to balance into mole concept, and plus lambda m infinity of SO4 minus 2. Again, if you are going to dissociate it, 2 into lambda m Na plus, and then plus lambda m, and it will be C2O4 minus C2O4 minus 2. Again, if you are going to uh, dissociate this 2 into lambda m infinity H plus lambda m infinity SO4 minus. And what we need to prepare, which value we need to calculate is uh, lambda m infinity
H2C2O4.
H2C2O4. So if you are going to dissociate it in your mind, it will be 2 into lambda H plus lambda C2O4 minus, like this. Yes or no? This is M, this is M also.
Yes.
So concentrate on this. We need this and this only. Yes or no? So what we are going to do is equation number 1, 2, 3. So what we are going to do is 2 plus 3 and minus 1, because with the 2 and second and third equation, we are getting this and this extra. So we will just minus it. 2 plus 3. So 2 lambda infinity m Na plus lambda infinity m C2O4 minus 2 plus 2 into lambda m H plus lambda m infinity. This is SO4 minus 2, and we are going to minus first equation 2 into lambda m infinity Na plus, and then minus lambda m infinity SO4 minus 2. Yes or no? Now you can easily see that this SO4 and this SO4 will be cancelled, this and this will be cancelled, and this will combine to form lambda M infinity H2C2O4? Yes or no? So what we
Yes.
just did, 2. What is the value of this? 800 plus 700 minus 900. So 8715 minus 900 will be equal to 600 Siemens centimeter
600.
square per mole. Yes or no?
Yes.
Thank you. Let me know when you are done with this. Are you done with this?
Just a minute, sir.
Okay, okay. Take your time, no problem.
Done, sir.
Very good. I'm going to share another. Yes. Please do this question number 1.
Sir, is the option D?
No, not B. I don't think option B is correct. This is very easy. All molar conductivity is given. Okay. Should I explain it?
So is it B?
B, this?
Yes.
No, it's not B. Did you solve it or you just calculated in your mind?
I calculated in my mind.
Okay, just solve it. You will get your answer.
Sir, it's A.
What's your answer?
A.
A. That's good. A is the right answer. Okay. Do you need any explanation?
No, sir, I got it.
Question number 5.
Sir, is the answer D?
What is the answer?
D.
D. Let me just think. Now, what we need to make? So that's good. Question number 6.
Sir, is the answer D?
D, I think it's right answer. Yes, it's D. Can you solve question number 8?
Sir, is it B?
No, I told you that in equivalent concept, we don't need to balance. So the answer is C. We don't need to balance for equivalent conductance. Okay, but if it was
Yes, sir.
if it is molar conductance, then the answer will be 3Al plus 3. It will be multiplied by 3, and sorry, this will be the answer for molar conductivity.
Okay,
Okay. Okay, come to the question number 11.
Sir, is the answer B?
Yes, very good. It's B. Question number 30. Coriolis law is one of the most important topics from electrochemistry. That's why I'm giving you so many questions.
Sir, it's 390.71 ohm per centimeter square.
What is the answer?
C.
C. Very good. Okay, two more questions left. Can you do question number 12?
Sir, can you explain the 12th question?
What you just said?
Can you explain the 12th one?
Okay, 12th one. See, 12th one is like what is given, a specific conductance. A specific conductance, that means conductivity is given. Yes or no? Kappa is given
Yes.
as 0.012 per ohm per centimeter, right? And anything else given? Resistance is also given as 55 ohm. The cell constant we need to calculate. Cell constant. So what is the formula? Kappa, which formula I had given you? Wait a minute. I'm going to show you. If you remember, in the last class, yes, kappa is equal to conductance into cell constant. I had given the formula, yes or no?
Yes.
So cell constant, we need to calculate cell constant, right?
Yes, sir.
Cell constant will be equal to a specific conductance, yani kappa upon conductance G. What is the value of kappa? 0.012 upon what is the value of G? G is inverse of R resistance, yes or no?
Yes.
R will be go and multiply it by 0.012 into R is 50. So you can
Sir is 55.
0.12 by 5 constant 0.60. Yes
Yes.
or no? It will be sorry, it is 55. So approximately 0.66. Okay, per centimeter. Got it or not?
I got it, sir.
Okay, please write it and let me know. Then I'm going to give you another question.
That's it.
Very good. Now 13, it's done. 14, the last question for today.
Sir, can you explain?
It's also similar as the previous one. You can see molarity is given. Yes or no? Now see,
Yes.
I'm going to explain it. Question number 14. So molarity is 0.01 m and resistance is 40 ohm. Yes.
Yes.
And what we need to calculate is molar conductance. Okay. It's also given that having a cell constant is 0.4 centimeter. That means cell constant G star, that is equal to L by A, is equal to 0.4 per centimeter. Yes or no?
Yes.
Now see, molar conductance, we need to calculate kappa into 1000 upon m. Yes or no?
Yes.
Now you can see m is given, 1000 is given. We need to calculate kappa from this information. And kappa has a value. Kappa will be equal to cell constant upon resistance. Can I write it? Yes or no?
Yes.
From that formula, do you remember? A specific
Yes, I do.
conductance kappa will be equal to G into G star. And you know that this G is equal to 1 by R into kappa into G star.
Yes.
So that's why it's cell constant upon R. So 0.4 upon this 40. This will be 1 by 100. That means 10 raised to the power minus 2. So put the value 10 raised to the power minus 2 here and 10 raised to the power 3 here. And what is the value of m? That is 10 raised to the power minus 2. This will be cancelled. So the answer is 10 raised to the power 3. Yes or no?
Okay, sir.
Please write it.
This is it for today. In the next class, we will study about cell, electrode potential and all. Let me know when you are done with this.